Don't forget to subscribe and press the bell icon to never miss a video from testbook.com.
Hello friends, a very warm welcome to all of you. Hi Muthu, very nice to see you. A very good evening. So guys, please mind the background today. Actually, I'm in transit mode. So I'm not in Bangalore, I'm somewhere else. So I'm at my wife's place. So because tomorrow it will get settled, by the way, this thing will get settled. So kindly, please don't punish me for this. Guys, I hope you got the video the day before yesterday. That video was a recorded one. So in that video, we discussed a very simple question of stream function. So you might have observed that in the last two videos, I have kept the question simple. So as per the mechanical and civil schedule, whatever type of questions we have been getting, not schedule, gate paper. So as per mechanical and civil paper, whatever type of questions have come, so I have kept it simple only. But tomorrow when we will discuss Euler's equation, it would be better to go in a tough question. When we are discussing Bernoulli's equation, it would be better that we discuss 2-3 questions. Because questions of Euler's equation are becoming frequent. They are asking more and more questions from Bernoulli's equation in last few years. So it would be better that there we increase our level of toughness. So ठीक है फिर, without wasting any time, I don't want to waste your time. And guys, for your information, I have been observing that in last few days there has been a lot of activity on the NPTEL website. So once you get free from your preparation, you can look for certain certifications. Earlier also I told that they have launched a very unique course which is fluid mechanics for astrophysics. So like this, other courses are also coming into picture, and you can also look for Gyan courses. So all those third year students, second year students, they can use these opportunities to learn something. Gyan course, it happens in IITs, okay? Gyan course. So let us begin. So what is the topic for today? So quick revision. We will hardly spend 40 minutes and we will move on. We will switch off the video. So what is velocity potential function? Please be quick. Please be quick. What is velocity potential function? Anyone who is watching, please be quick. What is velocity potential function? What is velocity potential function? Anyone, please be quick. Velocity potential function. Velocity potential function. Please be quick. Muthu, Kumar, Muthu, and anyone else who is watching the video. Anyone else who is watching the video. So guys, I hope you remember that when we were doing fluid kinematics chapter, in fluid kinematics chapter, we talk of two functions. One is a stream function and other one is a velocity potential function. Say for example, when we talk about stream function, so the definition of stream function says stream function. So definition of stream function says that whenever the flow is incompressible, you can define the flow by a scalar function psi. So actually psi is a function of coordinates. What is the value of psi at point x comma y? If the flow is unsteady, this psi can be a function of time also. Nowadays, even for compressible flow, there is a stream function. Believe me, even for compressible flow, there is a stream function. But in our syllabus, we do not consider it. Actually, there is a stream function for compressible flow, but we do not consider it. Also, in our syllabus, we talk of 2D flow only. But there is a stream function for 3D flow as well. That is X, Y, Z and X, Y and Z. But please ignore those things if you read anywhere. We are not going to consider them in our syllabus. In our syllabus, if the flow is unsteady, definitely psi will be a function of time. But if it is steady, it will not be a function of time. Muthu, no worries beta. So beta, but only thing is that all those people who are giving GATE exam 2021. So for them, these videos are like revision videos. They are not proper content videos. They are revision videos. These are revision videos. So definitely you guys can watch these revision videos and utilize them. But once the GATE exam is over, so second year, third year students, there is an information. So in the first week after the exam of mechanical, I will launch a course of complete fluid mechanics for mechanical civil ISRO DRDO BARC XC. So it will be a combined course which would be actually based on your semester syllabus. तो एक कंप्लीट फुल फ्लेज्ड कोर्स बनाएंगे 140 आवर्स के करीब, जो कि प्रैक्टिकल ओरिएंटेड होगा. सो मेरा एम है कि यू शुड गेट मार्क्स इन गेट 2022, बट यू शुड ऑल्सो अंडरस्टैंड द मैजिक ऑफ दिस सब्जेक्ट. सो वी विल डू दैट. ठीक है. एनीवेज लेट अस कम बैक. सो देयर इज अ स्केलर फंक्शन which was called as stream function, and if we derivate this stream function with respect to x, then we get negative of y component of velocity, and if we differentiate this stream function with respect to y, we get x component of velocity. So definitely there are some properties of stream function, and there is some methodology of using the stream function for understanding the flow. Okay, but today we will talk of velocity potential function. So like you have the condition of incompressible flow, similarly we have the condition of irrotational flow. So if the flow is irrotational, Muthu beta, you don't worry beta. Actually, for SSC JE, the classes will start separately and they will start early. So, par bete, for GATE, the pattern of study is different, and for SSC JE, the pattern of study is different. So you should watch these videos if you are liking it, if you are in third year, if you are preparing for GATE IES also. पर अगर सिर्फ SSC JE देख रहे हैं ना, so in 1 week or so, the proper SSC JE classes will start. So you have to definitely watch them. ठीक है? So when we are talking of irrotational flow, there is a function which comes into picture, and it is called as velocity potential function. Now, if we differentiate the velocity potential function with respect to x, we get the negative of x component of velocity. If we differentiate the velocity potential function with respect to y, we get the negative of y component of velocity. Okay? So this is the mathematical definition of the function. So what happens is, in certain books, this is written as positive, but you please don't worry about it. Actually, that positive or negative is a sign convention. So either you keep both as negative or you keep both as positive. Now in India, we follow negative signs. So I will keep it as negative only. So velocity potential function is a function which is defined when the flow is irrotational, and if we differentiate this function with respect to a space coordinate, we get the corresponding velocity component but in negative. Okay. Now this function also, it has certain properties. So let us see what are those properties. So just like stream functions, there are certain properties or certain formulas. So I hope you remember that when the fluid flows, then in Eulerian approach, at every point there is a linear strain rate. So at every point the particle will deform. So how fast the x length of particle is changing with time, that is the rate of linear strain along x. And how do you denote it? You denote it by del u by del x. But if I go by the definition of velocity potential function, I can say that u, this is nothing but minus del phi by del x, right? So what will be this? This will be minus del square phi by del x square. So a rate of linear strain along the x direction. So basically, if there is a particle and this side of the particle is x, so when the particle will move ahead, how fast this length will change with the time, that is rate of linear strain in x direction. So this is simply equal to negative of del square phi by del x square. Similarly, if you talk of epsilon dot y, if you will talk of epsilon dot y, please check, please make a guess what it will be. I think that epsilon dot y will be minus del square phi by del y square, minus del square phi by del y square. So guys, I hope the people who are watching the video, they are understanding it. Please note that you can interact with me anytime. If you feel I have made a mistake, then you can tell me anytime. If you feel that you have a doubt, then also you can tell me anytime. The idea of these videos is to revise the concepts. The idea of these videos is not to read the video, go through the topic freshly. I am considering that you already know the topic and you are here to revise. But please do let me know if there is a doubt. I will try to clear it for you. So this is how you express the rate of linear strains in terms of phi. Similarly, there will be a rate of shear strain also. There will be a rate of shear strain also. So how do you write rate of shear strain? The rate of shear strain is written as gamma dot xy. So that will become del v by del x plus del u by del y. Obviously, for our 2D planar flow, hi Hardik, how are you? Nice to see you. So Hardik, beta, I'm revising velocity potential function today. So, matlab every day I go through a 40 minutes video to revise one topic in order. So today we are revising velocity potential function. Tomorrow we will do Euler's equation, then Bernoulli's equation. So like this, every day I am doing a video, and if it is useful, you can definitely watch it. Okay? So gamma dot xy, gamma dot xy. Now what is a v? I hope you remember just one slide back we wrote down v. What is v? V is nothing but minus del phi by del x. Minus del phi by del y. And similarly, if I talk of u, it is nothing but minus del phi by del x, right? Now please check. So gamma dot xy, it is minus of del square phi by del x del y plus minus del square phi by del y del x. Now you will say, sir, there are two terms. What is the difference between the terms? There is no difference between the terms. Actually, the two terms are same. So you might say that first we derivate phi with respect to y and then with respect to x. Here we derivate phi, differentiate phi first with respect to x and then with respect to y. But as per the rules of calculus, whatever may be the order of differentiation, the final result will be same. So this term and this term, they are exactly same. So if you will take a minus common, they will add up and you will have a factor of 2. So gamma dot xy, it is nothing but minus 2. It is nothing but minus 2 del square phi by del x del y. You can also write it as del y del x. That is not going to matter. Okay. So this is the formula of rate of shear strain in terms of phi. But please remember, you can define phi, you can use the term phi only if the flow is irrotational. Now guys, just try to think, we are expressing the flow in terms of velocity potential function. We are expressing the flow in terms of phi, which can be defined only when the flow is irrotational. So what do you feel? What must be the formula of ohm vector, that is vorticity? What must be the formula of ohm vector, that is vorticity in terms of phi? Kindly check. What do you feel? So it is del v by del x minus del u by del y. I have not written angular velocity, I have written vorticity. Del v by del x minus del u by del y. Just think for yourself. Bhaiya, phi can be defined only when flow is irrotational. So if the flow is irrotational, this ohm z is going to be 0. So actually, if you define the flow by phi, the flow will be irrotational. Now guys, please check. This means del v by del x minus del u by del y, that has to be 0. But what is v? V is del phi by del x. So this will minus del phi by del x. So this will become minus del square phi by del x square. What is u? It is minus del phi by del y. So this will become plus, this will become minus del square phi by del y square minus del square phi by del y square. Guys, please check if I made a mistake. So del v by del x minus del u by del y. Oh, yes. Sorry. I made a mistake. Sorry. I made a mistake. So what is V? V is del phi by del y. So this will become minus del square phi by del x del y. है ना? And this will become minus del square phi by del y del x. But please note, here you have a minus. So minus and minus will become plus. Now please check. These two are same only. So what you will get? You will get a 0 only. So I hope you remember that from here we prove that velocity potential function is defined only for irrotational flow. आबरा बेटा थोड़ा सा गड़बड़ है. Laplacian equation कब आता है? Laplacian equation comes into picture when? Laplacian equation comes into picture when? If the flow is incompressible. If the flow is incompressible, then your rate of volumetric strain rate will be 0. But how do you define rate of volumetric strain? So rate of volumetric strain is written as del square phi by del x square plus del square phi by del y square. Right? Now this will become 0. Right? अभी मैंने prove नहीं किया है तो ये मैं अभी इसको करूँगा. ठीक है? Okay, so we have written linear strain rates, we have written shear strain rates, and we know that vorticity vector is going to be 0 because we are talking of flow defined by velocity potential function. Now, one more thing. One last thing is left. So we have defined linear strain rates, we have defined volumetric strain, shear strain rates, but how do you write volumetric strain rate? Please note, till now I have not said that this is an incompressible flow. This can be a compressible flow also. Only one condition is there, and that condition is this one, irrotational flow. That condition is irrotational flow. Only one condition is necessary. So the flow can be compressible as well as incompressible. So what you will do, you will define a term that is volumetric strain rate. So del u by del x plus del v by del y. Now substitute u. So how do you write u? That is minus del phi by del x. So this will become minus del square phi by del x square. What is del v? So v is minus del phi by del y. So this will become minus del square phi by del y square. And obviously you can write it like this, minus del square phi by del x square plus del square phi by del y square. I have taken a y minus as common. Now what you do, you can write like this also, del square by del x square plus del square by del y square and phi, right? Now guys, check what will happen. Actually you will get a term of match the following. आपको क्या मिल जाएगा? Match the following का term मिल जाएगा. How? I think I can split the bracket as del by del x I cap plus del by del y j cap dot product with del by del x I cap plus del by del y j cap. I think I can split the bracket like this, and phi is a scalar function. Now what is this? This is gradient. What is this? This is gradient. So what you will have? You will have minus gradient dot gradient of phi. So this is also how you can write the volumetric strain rate in terms of velocity potential function. Correct, Abra? Abra, please check if I am correct. Please check if I am correct. So if someone asks you in match the following, what is this? This is nothing but volumetric strain rate expressed in terms of velocity potential function. And you can use the term velocity potential function only if the flow is irrotational. Okay. Now, till now, the flow can be compressible as well as incompressible also. But let me suppose the flow is incompressible. Let us suppose the flow is incompressible. So you will say, if flow is incompressible, then your volumetric strain rate is going to be 0. But what is the formula of volumetric strain rate in terms of velocity potential function? It is minus of del square phi by del x square plus del square phi by del y square, right? This is the formula of volumetric strain rate. So if the volumetric strain rate is 0, this is 0. So what will happen? Del square phi by del x square plus del square phi by del y square equal to 0. So what we are getting is that for incompressible flow, the phi is satisfying the Laplace equation. The phi is satisfying the Laplace equation. ठीक है ना? So I hope you remember this. Now, I also said one more thing we did. One more thing we have done. So what is that thing? So you guys told me that, sir, phi is a function of x, y and maybe time if the flow is unsteady. So this is going to tell us what is the value of phi at a particular position. If we differentiate it, so stream function के लिए flow को incompressible होना पड़ेगा. Very good, very nice. Now, if we differentiate this equation d phi, so you will have del phi by del x dx plus del phi by del y dy. Now, many students, they say, sir, what is the meaning of this d phi? So, Abra will tell us, sir, d phi means it is the difference of function value between 2 points. So actually there are 2 points. One point is x comma y. Here the value of function is phi. There is another nearby point, x plus dx comma y plus dy. Here the value of function is phi plus d phi. So d phi is nothing but the difference of function value between two nearby points whose coordinates differ by dx and dy. So this is the meaning of this equation. D phi is equal to del phi by del x dx plus del phi by del y dy. So what will happen? D phi, this will become del phi by del x, that is minus u dx, del phi by del y, that is minus dy. So this is the difference of velocity potential function value between two nearby points. So if the points are far away, you can simply integrate this equation and you will have minus u dx from point 1 to point 2 minus v dy from point 1 to point 2. This is the difference of velocity potential function value between 2 points. Okay. Now guys, I hope you remember streamline. When we talk of streamline, so this I am writing in rough. So streamline is a line of uniform stream function value. Streamline is a line of uniform stream function value. Say, if this is a streamline, then all the points of the streamline, their stream function value is going to be same. So if you take point C and D, then psi C is equal to psi D because the 2 points lie on the same streamline. But psi A and psi C, they may or may not be equal. Okay, why? Because the 2 points lie on different streamlines. But psi A equal to psi B because they lie on same streamline. Psi C is equal to psi D because they lie on same streamline. So you say streamline is a line of uniform stream function value. Similarly, you guys tell me that, sir, like we define streamlines, similarly we define equipotential lines. What do you define? Equipotential lines. You will define equipotential lines. Now, equipotential lines are the lines of uniform potential function value. ये कौन सी lines हैं? Uniform potential function की values हैं. Uniform potential function की values हैं. So what do you mean by uniform potential function value? So it simply means if there is an equipotential line and you take 2 points on the same line, then phi value here and phi value here, it is going to be the same. So if there are 2 points, nearby points x comma y and x plus dx comma y plus dy, then the velocity potential function value of the 2 points will be same. Why the function value will be same? Because both the points lie on the same line. So for these 2 points, the phi value is equal. So what is the difference of phi value? That is 0. But for any random points, just now we saw that the difference of phi value is minus u dx minus v dy. So this will become 0 now. So what you will have? You will have dy by dx equal to minus u by v. So if there is a line where the velocity potential function value is everywhere same, there is a line where velocity potential function value is everywhere same, in that case that line will be called as equipotential line. And the dy by dx, so what will be dy by dx? Dy by dx will be the slope of this line. Dy by dx, that is the slope of the line, will be minus u by v. हाँ आबरा बेटा psi1 माइनस psi2 इक्वल टू डिस्चार्ज. जब भी फ्लो इनकम्प्रेसिबल है तो आप साई फंक्शन डिफाइन कर सकते हैं, और अगर साई फंक्शन डिफाइन कर दिया तो साई फंक्शन की प्रॉपर्टी तो एप्लीकेबल होगी ना. ये तो साई फंक्शन की प्रॉपर्टी है. दिस इज अ प्रॉपर्टी ऑफ साई फंक्शन दैट डिफरेंस ऑफ साई विल गिव यू डिस्चार्ज पर यूनिट विड्थ. ठीक है ना, वो तो हमेशा ट्रू है, बस फ्लो इनकम्प्रेसिबल होना चाहिए. ओके. Now next point. So what do we have? If you remember, along a streamline, I'm not talking of equipotential line first. I'm talking of streamline. What I'm talking about? Streamline. So along the streamline, d psi value, stream function value, is equal to 0. Because along a streamline, the stream function value is a constant. This means the component of gradient of psi along the streamline, this is 0, right? I hope you know gradient vectors. Yes or no? I hope you know gradient vector. So gradient vector is the direction along which a function value changes at maximum rate. You might have done this in vector calculus. जिस डायरेक्शन में फंक्शन मैक्सिमम रेट पे चेंज होता है, उस डायरेक्शन के अलोंग ग्रेडियंट वेक्टर होता है. बट अलोंग द स्ट्रीमलाइन द साई वैल्यू इज कांस्टेंट. Therefore, the gradient component along the streamline will be 0. So, if gradient component along the streamline is 0, this means the gradient vector is perpendicular to the streamline. Gradient vector is perpendicular to the streamline. Gradient of stream function value is perpendicular to the streamline, right? Now guys, please note, let me say that the flow is incompressible. So if the flow is incompressible, then psi will come into picture. So if the psi will come into picture, you will have u equal to del psi by del y, and v equal to minus del psi by del x. But let me also say that the flow is irrotational. So if the flow is irrotational, you can also define a velocity potential function. Then u will be equal to minus del phi by del x, and v will be equal to minus del phi by del y. So when the flow is both incompressible and irrotational, you will get this set of equation which is called as Cauchy-Riemann equation. Now, how do you write the slope of a streamline? So you say the dy by dx for psi equal to constant, that is a streamline. This is equal to v by u. And what is the slope of equipotential line? You say dy by dx for phi equal to constant, that is minus u by v. Now, what is the product of two slopes? The product of two slopes is minus 1. So you say equipotential line is perpendicular to streamline. This means equipotential line is along the gradient of stream function. Equipotential line is perpendicular to streamline, therefore equipotential line is along the gradient of stream function. Yes or no? Please be quick, please do let me know. I think ये चीज मैंने पहली बार बताई है, क्लास में कभी डिस्कस नहीं किया इस चीज को. मतलब many times I have not discussed this with students, gradient terms, क्योंकि पूछा भी नहीं जाता है gradient of stream function. Yes or no? Please do let me know if I am correct. Please do let me know if I am correct. Hi Reddy, how are you? Nice to see you, Reddy. So hope everything is going good. So Reddy, today na I had a class of maths. So there was a guy. So his name was also Sai Reddy. So when I checked, I thought it's you, but then I realized that your online name is Sai Tejeshwar Reddy. Hello Rajwant, very nice to see you. हाँ, आभरा समझ आ गया ना बेटा? So guys, these are the properties of the velocity potential function. These are important properties of velocity potential function. Actually, velocity potential function has a lot of role when you are talking of potential flows. Sink and source, you might have checked in your syllabus. But I don't do it much because it's not a part of our GATE syllabus. GATE syllabus में इतना नहीं आता है. But just now I was having a talk with Abra. So if you are giving a paper of XC, then you have to do a little extra. You have to talk about sink and source also and doublet also. So I told him that in Sengel, approximate solution of Navier-Stokes equation. So in this chapter, you can read extra if you are giving the paper of XC. Okay. Now guys, what is the question that we can get in GATE exam? So in the question, they will give you a velocity potential function. So they will say a flow is explained by this velocity potential function. Now they will ask you, what is the velocity? What is the velocity at 2, 3? Let us say this is the first question. Let us say this is the first question. So first of all, they might ask you, a flow is defined by a velocity potential function phi equal to 2xy. Is the flow rotational? Is the flow rotational? Is the flow irrotational? Is the flow compressible? Is the flow incompressible? Okay, so first question is this: incompressible and compressible. So definitely you will say कि भैया the flow is defined by velocity potential function. So if we are defining a flow by velocity potential function, this simply means if we are defining the flow by velocity potential function, this simply means the flow is irrotational. Yes or no? Am I correct? Am I correct? Am I correct? The flow is irrotational. Is this the final answer? अच्छा, 2 डिफरेंट क्लास लेके. सो राजवंत बेटा, अभी तो मैं ना मेरे को जो लगा, सो क्या हुआ था कि ना एक हमने लेक्चर किया था एक दिन, तो मैंने सोचा था कि मैं 10-11 घंटे में हीट ट्रांसफर रिवाइज करा दूंगा और 10-11 घंटे में एफएम भी करा दूंगा. सो क्या हुआ कि हीट ट्रांसफर का जो रिवीजन हुआ ना बेटा, वो तो बढ़िया चला गया. 10-11 घंटे में हम ऑलमोस्ट एक चीज रिवाइज कर पाए थे. बट यार तेरे को फ्लूइड मैकेनिक्स में मैं भी थोड़ा ज्यादा बह जाता हूँ. तो फ्लूइड मैकेनिक्स में क्या हुआ, रिवाइज करते करते 8-9 घंटे हो गए, मगर 2 ही चैप्टर रिवाइज हुए थे. तो फिर उस दिन मुझे भी लगा कि यार देखो, पता है क्या है, आप सभी लोग अपने अपने टीचर से पढ़ रहे होंगे. सो मेरे दिमाग में ये आया कि अगर मैं एक दिन हम फ्लूइड मैकेनिक्स रिवाइज कर रहे हैं और ऐसे 4-4 घंटे एक चैप्टर पे लगा रहे हैं, तो आप लोगों के लिए भी मैं कंफ्यूजन क्रिएट कर रहा हूँ. क्योंकि अभी जिन टीचर्स की क्लासेस चल रही हैं, जो प्री प्लान है, वो ज्यादा इंपॉर्टेंट है ना. हमें तो उनको फोकस करना चाहिए, जो करंट क्लासेस चल रही थी टीचर्स की. तो फिर मैंने ये प्लान बनाया कि मैं ना एक काम करता हूँ, डेली बेसिस पे 40-50 मिनट्स का एक टॉपिक डालूंगा ताकि वो टॉपिक रिवाइज हो जाए. तो हम रोज रात को एक टॉपिक डालते हैं 40-50 मिनट्स का, वो रिवाइज करने के लिए, और इसका एक 2 क्वेश्चन कर लेते हैं, 2-3 क्वेश्चन करते हैं, उससे रिवाइज करते हैं. और मैंने प्रॉमिस किया हुआ है कि दोनों जितने भी चैप्टर्स बचे हुए हैं, जो भी चैप्टर्स हैं, चैप्टर्स का भी रिवीजन सेशन डालना है मैंने, बट ना वो फुल डे वाला नहीं डालूंगा क्योंकि उसमें आपका टाइम वेस्ट होगा. सो मैं मतलब पहले से ही लिख के रखूंगा स्लाइड्स पे, ताकि काइनेमेटिक्स 1 घंटे में रिवाइज हो जाए, 1-1.25 घंटे में, डायनेमिक्स 1-1.25 घंटे में रिवाइज हो जाए. अच्छा, वही नोट्स फॉलो करते हो. ये कब बनाए थे नोट्स? ये मई के नोट्स हैं क्या? बिकॉज इन मई 2020 आई थिंक आई हैड वन ऑफ द बेस्ट क्लासेस. तो मई 2020 में काफी बढ़िया नंबर ऑफ आवर्स थे, तो बहुत बढ़िया क्लास बनाया था. तो एक बार चेक करो गाइस. नाउ गाइस प्लीज नोट, तेजेश्वर बेटा, यू नो this is an MSQ question and there are 2 correct answers in this. This is an MSQ question and in this MSQ question there are 2 correct answers, you know. Actually the flow is incompressible also. Now you will ask me, sir, how come the flow is incompressible? Just now you said that velocity potential function is defined only for irrotational flow. There is a no role of compressible or incompressible, है ना? So actually what happens, I hope you remember, just a few minutes back we said that velocity potential function gives the value of volumetric strain rate. What is the value of volumetric strain rate? Del square phi by del x square plus del square phi by del y square, है ना? This is the value of volumetric strain rate in terms of velocity potential function. Now what you do, you find out this value because the function is already given to us. So I think if I will do del phi by del x, if I will do del phi by del x, I will have 2y. And if I will do a derivative again, so del square phi by del x square. Now y is a constant, right? So this derivative will become 0. Similarly, phi is equal to 2xy. So when I will do del phi by del y, I will have 2x. And when I will do the derivative again, del square phi by del y square, then this will become 0. ऐसा ही होगा ना? Now check, del square phi by del x square is 0, del square phi by del y square is 0. So 0 plus 0 is 0. So volumetric strain rate is 0. So in this particular question, definitely the flow is irrotational. But since volumetric strain rate is coming out to be 0, the flow is incompressible also. अच्छा, राजवंत बेटे एक काम कर, ये मेरा फोन नंबर है, कॉन्टैक्ट मी, ठीक है? मेरे से बात करना, मेरे को एक बार देखना पड़ेगा, मतलब आपका और मेरे बीच में कुछ मिसिंग तो नहीं है, ठीक है? क्योंकि मैंने ना जो पुराने स्टूडेंट्स थे उनके साथ जैसे जब भी बात होता है तो कंप्रेसिबल फ्लो, टरबाइंस वगैरह किया उन्होंने, तो मैंने यूट्यूब पे वीडियोस डाले थे और उनको जब टाइम मिला ना तो उन्होंने मेरे से डिस्कशन किया, मेरा वीडियो देखे थे. तो एक बार मेरे से बात करना, मुझे पता लगे कि आपका कैसा चल रहा है काम, ठीक है? हम डिस्कस करेंगे टॉपिक वाइज. अच्छा सर, आरआरबी एनटीपीसी में 65 नंबर में सिलेक्शन होगा या नहीं? राजेंद्र सॉरी बेटा, एक्चुअली आई हैव डोंट हैव नॉलेज ऑफ आरआरबी एनटीपीसी, सो आई एम इनटू गेट, एसएससी जेई और आईएएस और मेजरली गेट, तो मैं ना आपको वो इंफॉर्मेशन नहीं दे पाऊंगा, ठीक है? ऐसा, सो वो आपको चेक करना पड़ेगा बाकी टीचर्स के साथ. Okay, so this is a irrotational as well as incompressible flow. So guys, please remember, whenever they are asking you na irrotationality, they are asking you incompressibility. So there are different conditions for them. So you have to check them separately and you have to check them both. If you do not check them both, you will get a wrong answer. ठीक है ना? This is an MSQ question. Now the question will be, what is the velocity value? अरे वीरेंद्र, हाय बेटे वीरेंद्र, सॉरी मैं तेरा ना मैसेज नहीं पढ़ कर पा रहा रिप्लाई. सो एक्चुअली क्या हुआ, 2-3 साल बाद आया हूँ ससुराल, ठीक है? तो काफी मिलना जुलना, तू समझ रहा है, बाकी लोग भी आ रहे थे, तो ना मैं 2-3 दिन से रिप्लाई नहीं कर पा रहा और मैं ना ट्रांजिट मोड में हूँ. तो अभी 4-5 दिन में बैंगलोर जाऊंगा, बट अभी ये क्लास ओवर होती है ना, तो मैंने आभरा को भी बोला है उसका काम करके दूंगा और तेरा भी सोचा हुआ था कि बात करूंगा तेरे से, ठीक है? बस ये वीडियो ओवर हो जाए, 10:30 तक खाना वाना खा के फिर बात करता हूँ. सो देख रहा है मेरा एक्चुअली लोकेशन चेंज हो गया है, तो यहाँ ट्रॉली लगी हुई थी, अभी टांगी है चादर. ठीक है, तो मैं करता हूँ कॉल. बस यार वो 2-3 दिन से ना ट्रैवलिंग में था मैं. So del phi by del x equal to minus u and del phi by del y equal to minus v. So we know that if the velocity potential function is given to us, we can find out the expression of u. So u is equal to minus del phi by del x. Now what is phi? Phi is 2xy. So del phi by del x, y will be treated as constant. So this will become, y will be treated as constant. X has power 1. So this will become minus 2y. When we talk of v is equal to minus del phi by del y. This will become minus 2x, right? So these are the expressions of velocity components at a point x comma y. So at a point x comma y, the velocity along the x-axis is minus 2y and the velocity component along the y-axis is minus 2x. So at this particular point, these are the velocity components of the particle. Now in our question, x comma y is 2 comma 3. So what is the velocity at 2 comma 3? So velocity at 2 comma 3 will be minus 2y. U is equal to minus 2y. So minus 2 into 3, that is minus 6 units. And v at the same point 2 comma 3, that will be minus 2x. So minus 2 into 2, that is minus 4. So these are the velocity components. Hello Swagita, a very good evening. So Swagita, beta, I think you are new to this series. So every day 40 to 50 minutes we spend on a topic of fluid mechanics. So my aim is for GATE exam. So my aim is before civil paper we have to cover one topic daily 40 minutes. So uska revision, not all topics definitely, but important topics. And once civil paper will be over, then there will be one topic left for mechanical, that will be compressible flow. So civil and mechanical common topics I am covering daily. ठीक है? चलो फिर आगे बढ़ते हैं. We have found out the velocity components. Now the question is, next question can be find out the shear strain, linear strain rates. So linear strain rate is nothing but epsilon dot x. That is del square phi by del x square. Del square phi by del x square. In fact, minus of del square phi by del x square. So a few moments back we saw del square phi by del x square equal to 0. Similarly, when we say epsilon dot y minus del square phi by del y square, but just a few moments back we saw this is also equal to 0, right? Now can't anyone tell me what is the implication of this 0 term? What is the meaning of this 0 term? Can anyone tell me? Please be quick. Abra, Virender, Swagata, Swagatika and Rajwant, Rajender. So all of you, please be quick. Please do let me know. Bhaiya, if the linear strain rates, both the linear strain rates are 0, both the linear strain rates are 0, then what is the meaning of this? What is the meaning of this? Linear strain rate means size. Linear strain rate means size. So when the particle is moving ahead, its size is not changing. Its shape might change, but its size is not changing. Its size is same. So size means length, है ना? Now linear deformation नहीं हो रहा, बिल्कुल भी नहीं हो रहा linear deformation. Now next they might ask you what is gamma dot xy. So a few moments back we saw the formula of gamma dot xy. So I think the formula of gamma dot xy was minus del square phi by del x del y. So you can perform this differentiation in any order. Now what is phi? What is phi? It is 2xy. So first I will do del phi by del y. It is 2x. Then I will do del by del x of del phi by del y. So that will become 2, right? So your answer will be minus 2 into 2, that is minus 4. So gamma dot xy is non-zero. But linear strain rates are 0. This means when the particle is moving ahead, it is not changing size, but it is changing shape. It is not changing volume, but it is changing shape. तो जब ये fluid particle आगे बढ़ रहा है, भैया पानी का पार्टिकल है, पानी का पार्टिकल डिफॉर्म तो करेगा मगर उसका वॉल्यूम चेंज नहीं करेगा, और यहाँ पे साइज में भी चेंज नहीं आ रहा है. समझ रहे हैं? क्लियर है ना? क्लियर है? सो ध्यान रखना है, डिफॉर्मेशन तरह तरह से हो सकती है. डिफॉर्मेशन कैन हैपन इन मेनी वेज. So there is a possibility like this. There is a possibility like this. This is 2, this is 3. When the particle moves ahead, this remains 2 and this remains 3. So there is a change in shape, no change in size. Or it can happen like this. 2, 3, this becomes 1, 6. So there is a change in size, change in shape, but no change in volume. तो इस तरह से अलग अलग तरीके से डिफॉर्मेशन हो सकता है. Deformation can happen in many ways. Let's be quick. Last question. What can be the last question from this? So they are asking you, phi is given to us 2xy. What is the velocity potential function of the flow? So just like we did in stream function. So in stream function, we found out the velocity potential function. Here from velocity potential function, we will go inverse. We will find out the stream function. But again, what we have to do? First of all, you will say, ki bhaiya, they are saying a flow is defined by velocity potential function. This means the flow is irrotational. So once the flow is irrotational, you have to check the volumetric strain rate. Now in this particular example, volumetric strain rate was 0. So if volumetric strain rate is 0, the flow will be incompressible also, right? And once the flow is incompressible, then you can define psi. So guys, please note, these are separate conditions. They are not related to one another. So whenever you are finding psi, first of all, you have to check whether the flow is compressible or incompressible. But we are lucky in this case. So flow is incompressible. How did I check? From volumetric strain rate. Therefore, psi can be defined. Now the question is, how do you find out psi from phi? Very easy. Bhaiya, when the flow is both incompressible and irrotational, we have u, which is equal to minus del phi by del x equal to del psi by del y. So very simple. If we partially differentiate phi with respect to x and take a negative of it, that is the same as partial differentiation of psi with respect to y. So what is phi equal to? Phi is equal to 2xy. So what will be del phi by del x? It will be equal to 2y. So you will say minus 2y is equal to del psi by del y. So if I partially differentiate psi with respect to y, I get minus 2y, and Abra is totally correct. Abra is telling us that this is Cauchy-Riemann equation. Very good. Totally correct, Abra. So देखा, आप लोगों से बात करने से मुझे भी नई नई चीजें पता लगती हैं, है ना? Now check del psi by del y. So del psi by del y is equal to minus 2y. Now please check, when I was performing this differentiation, it is partial differentiation with respect to y. So x was treated as constant. So if you will go back, if you will integrate again, you will have minus 2y square by 2, that is minus y square plus a constant of integration. But instead of constant of integration, we will have a pure function of x. I hope everyone knows this. कि भैया, in case of partial integration, you do not put a constant of integration but a function of integration. So I hope ये सभी को पता है कि when I am doing partial integration with respect to y, I will get a pure function of x. If you do not know it, please do let me know. Please type in and I will show you how. ठीक है? But I am assuming that you have done this. Now the question is, sir, what is this pure function of x? How we are going to find it? So I will say, let us go with the other equation of the Cauchy-Riemann pair. So other equation says that minus v is equal to minus del psi by del x or minus del phi by del y. So if I will partially differentiate phi with respect to y, in our example we will have 2x. So minus del psi by del x, this is equal to minus 2x. So minus and minus will cancel out. This means if we partial differentiate psi with respect to x, we get 2x. Now you partial integrate, keeping y as constant. So you will have 2x square by 2, that is x square, and a pure function of y. Now, whether you find out psi from this equation or from the other equation, your answer must be same. But what is the other answer? Other answer is minus y square plus pure function of x. You compare them. This is the pure function of x. This is the pure function of y. So your final answer psi is equal to minus y square plus x square. So for a velocity potential function phi equal to 2xy, psi value is equal to minus y square plus x square. ठीक है? Yes, they are analytic. They are analytic. Totally correct, आबरा. आबरा बेटा ये ना शायद आपने पार्शियल डिफरेंशियल इक्वेशन मैथ्स में भी पढ़ी है. वो पढ़ी होंगी कॉशी-रीमन इक्वेशन. वो सेम चीज ही है. वो सारा जो मैथमेटिक्स है ना वो फ्लूइड मैकेनिक्स से ही डेवलप हुआ है. हाँ, x square minus y square or minus y square plus x square. So guys, this is the type of question that you can get from velocity potential function. So they will give you velocity potential function. They will ask you whether the flow is irrotational or incompressible. They from velocity potential function, they can ask you the velocity at a point, rate of linear strain rates at a point, rate of shear strain rate, rate of volumetric strain rate. But if they ask vorticity, that is going to be 0 because the flow is irrotational. Now further, if the volumetric strain rate is 0, the flow will be incompressible also. So stream function will also come into picture. So they might ask you what is the stream function for the flow. ठीक है ना? So that's all for today. Tomorrow's video and day after tomorrow, the video will be a little lengthy. Because I feel we should practice not one question but at least 2-3 questions in both the cases. So I think tomorrow we are going to talk about Euler's equation, and day after tomorrow either it is vortex flow or Bernoulli's equation. So Euler's equation, Bernoulli's equation, I am going to take good amount of time. So you can expect 1 hour, 15 minutes or 1.5 hours in both the topics. So if you are watching the video, if you are revising through these videos, then please do keep time for this. So Abra, Tejeshwar, Swagatika, Virender, anyone who is watching the video, any doubt? If you have a doubt, guys, you can ask me, else I will leave. Please do let me know. If there is a doubt, you can ask me. अच्छा हाँ आबरा, अच्छा. So आबरा बेटे वो चलेगा ना जो मैंने सोचा है कि 1-1 घंटा तोड़ के, क्योंकि मैं तेरे को फिर फोन पे बताऊंगा एक्चुअली क्या प्रॉब्लम है. सो वो मैं डिस्कस नहीं कर सकता इधर ऑनलाइन, बट वो तोड़ के अगर मैं सेशन बनाता हूँ, जैसे मान लो अगर मैं परसों काइनेमेटिक्स डाल दूँ, नेक्स्ट डे डायनेमिक्स डाल दूँ, 1.25 घंटा, क्योंकि अगर सिंगल वीडियो बनाऊंगा ना वो 1.25 घंटे में बन जाएगा. तो 1.25 घंटे में एक चैप्टर रिवाइज हो जाएगा. सो दैट वुड बी गुड. बट अगर मैं फुल वीडियो डालता हूँ तो मुझे लंबा स्लॉट चाहिए, और तेरे को पता ही है मेरे केस में थोड़ा काम स्लो होता है. तो मैं रिवीजन वीडियो जरूर बनाता हूँ, बट उसको तोड़ के बना लेते हैं. वो मुझे परमिशन में मिल जाएगा आसानी से. ठीक है? ओके. एंड सॉरी फॉर द बैकग्राउंड एंड लाइटिंग टुडे. दिस विल नॉट हैपन टुमारो. टुमारो आई विल रेक्टिफाई दिस. ठीक है? थोड़ा यार गरीब आदमी हूँ, थोड़ा सा मतलब ध्यान रखना. ठीक है? चलो. थैंक यू फिर. सी यू इन द नेक्स्ट वीडियो. सी यू टुमारो. बाय बाय. थैंक यू.